Good morning, everybody. This is an exciting day for me. I'm Greg Michaelson, one of the co-founders here at Zerve, and today we're talking about notebooks. The first time I was exposed to notebooks were in graduate school. I don't know if people know, but I think notebooks were invented back in the 80s by a guy at Berkeley who actually met at JupyterCon a while back. But anyway, my first exposure to notebooks was in class learning data science back at the University of Alabama. And we used tools like Jupyter. Of course, it was called IPython back then. RStudio is another notebook environment. I learned R in graduate school too. And throughout the years that I've been doing data science, notebooks played a pretty significant role, seeing as they're just incredibly popular. I think we did the math when we started Zerve that there were about 5 notebooks created per second for the entire, from like 2020 to whatever, right? It's an outrageous number of notebooks that are being created. There's a company, I think Datalore did a study that showed that there were millions and millions of notebooks made public on GitHub over the course of a 2 to 3 year period. So kind of a remarkable explosion of usage in recent years. And they're super truly useful. But I have here with me today, Joel Grus, who is one of my heroes, an idol by many, who's famous for a talk that he gave back in 2018 called "I Don't Like Notebooks" at JupyterCon, ironically, a conference all about Jupyter notebooks. So welcome, Joel. Would you just give us a quick intro and talk to us a bit about when you first encountered notebooks and what your experience is?
Yeah, so I've had a long, pretty windy career. I studied math originally, started out doing quantitative finance, pivoted to data analysis, pivoted to data science, wrote a book on data science, then pivoted to software engineering, to AI, machine learning engineering, and now I'm back, I guess, doing AI and engineering once again. What were my first, so I've been using Python for a really long time. I started using it around 2005. I was also in grad school, and I took a class in probability modeling that was based in MATLAB. And the way things worked is that the campus had a MATLAB site license that only worked on campus, and I lived off campus. And so I couldn't do my assignments at home because I didn't have access to MATLAB. And so I discovered that there was a language called Python and a tool, at the time it was called Numeric, today it's NumPy, that basically gave me a MATLAB-like experience. And that was when I started using Python. And then I've used it kind of off and on ever since. I think, when I got into data science, I started using notebooks because that was what people used for data science. I think even the first edition of Data Science from Scratch had a section at the end that said, oh, you should check out notebooks. That's what people use for data science. So I used them a little bit. I never thought about them that much. In 2016, I joined the Allen Institute for Artificial Intelligence, which is an AI research nonprofit in Seattle. This was before kind of the transformer revolution. And so a lot of NLP stuff back then was done on the Java stack using Stanford Core NLP. So when I joined, it was really a Scala shop. Everything was in Scala, which was not great for me. One, because I don't like Scala that much, and two, because I'm more of a Python person. But anyway, as transformers caught on and BERT caught on and GPT caught on, all of NLP started switching to Python. And so a lot of my coworkers who'd been doing Scala and Java forever needed to learn Python. So they came to me because I was, the Python guy. And one of my coworkers came to me and she said, I don't understand Python. And she's a very smart engineer, very good. And I was like, how can you not understand Python? It's not that complicated. And so I was like, bring your computer, show me. And she started showing me. And it turned out that she understood Python just fine, but she'd been working in a Jupyter notebook because someone told her to use a Jupyter notebook, and she had gotten the state all out of whack. And so none of the variables equaled what she thought they equaled. And that was why she was confused. And she wasted a few hours this way. And so I got mad. I went on Twitter and I tweeted, if anyone wants me to give a talk about why Jupyter notebooks are bad, let me know. I would love to have an excuse to write it. Someone at JupyterCon saw the tweets and responded and said, we can't promise we'll accept it, but you should submit it and let's see what happens. So I submitted it, they accepted it. And then I was like, this is going to be one of the most hostile audiences I've ever faced. So I better get my ducks in a row and know what I'm talking about. Right. And so I spent more time working on that talk than any talk I've ever worked on, but I spent a lot of time really digging into what is it that I do like about notebooks and what is it that I don't like about notebooks, just and beyond this, primary issue of hidden states, which was my starting point. And, it turned into a talk about a number of other things that really touched around some of my other big interests at the time, which was engineering best practices for researchers and for data scientists. And now, my joke is that instead of giving that talk, I should have started a company about better notebooks, because a lot of people have done that and been pretty successful with that. Whereas my talk, people like it, but it's just a talk. So
that's awesome. It's funny that you would say that, because at Zerve, we had exactly the same experience. So when we started Zerve, we were sitting in a room, me and the two other co-founders, and we had Mike McClintock there, who's our head of engineering, and he'd never been exposed to notebooks at all. And here we are building what at the time was a development environment for data science. And we're explaining to him how notebooks work. And let me actually just share my screen and kind of show what I showed him, a version of it anyway. And it was basically this. Only we did it in a notebook. Actually, I'll pull it up in a notebook. So I said A equals 1, and then I said A equals A plus 1, and then print A, right? So it would be 2. But then I did this, and this, and this, and this. And he was stunned. Mike was absolutely stunned that he was like, no, it can't possibly work that way. There's no way that somebody built it to do that. And so that's why I pulled up the screen and showed it to him. And maybe you can explain kind of what's going on there for folks that maybe haven't been in a notebook, or maybe more on the engineering side and have been scripting and things like that.
Yeah. So, when it comes to having a notebook like this, what's going on is not just what you see on the screen. So you run the first cell and it sets A to 1. You run the second cell, it increases A by 1 and then prints it. So then A becomes 2. And then you can run that second cell as many times as you want to, and it will keep changing the value of A. And now it also keeps incrementing, the number next to the cell. So it says this is, so obviously there's some kind of funny business going on here. And that the first thing we ran was A equals 1. The second thing, the seventh thing we ran was A equals A plus 1, print A. And clearly we did some other things between 1 and 7. But looking at this notebook, there's no way to actually know what were those things. And so that's where you can get confused from.
Yeah.
And once you start going back and forth, it gets even trickier.
Right. If you have a really long, complex notebook, I've seen notebooks where there are like markdown blocks telling you what order to run the cells in. And there are some really sort of pernicious bugs out there if you happen to run the cells in the wrong order or run a cell too many times or something like that, where it's like nothing equals what it's supposed to equal, but the code actually is written properly. And really the only way to fix it is to push this button here, which restarts your kernel. It basically clears all the memory so that none of the variables have any value, and then rerunning everything from scratch in the right order.
For sure. And one thing that I found, so there are a lot of people who really like notebooks, and Jeremy Howard gave an entire talk at a conference on why I'm wrong about notebooks. And so when you push people on this issue of, hidden things have happened and you don't know what they are, they'll say, yes, of course, that you're using the notebook wrong. You should know to restart and run all anytime you make a change like that. And I said, well, that's good. But most people, either don't know that or know it, but don't do it. So it causes a lot of problems still.
Yeah, to me, it seems like putting the turn it off and turn it on button as a top level navigation button in the app is a sign of a design flaw. But really, notebooks were designed from the beginning just to be scratch pads in like an academic setting.
I'm not even sure it always was a button. I think it might have been a drop-down menu at some point, but
or maybe not even present in
no, I mean there was always a restart and run all, but option, I think, because that was a common thing to do. But yeah.
Now, since you gave your talk, there have been lots and lots of startups that have popped up doing notebook type environments, but nobody really addressed that hidden state issue. Have you seen any movement on it apart from Zerve? We'll talk about Zerve in a bit, but have you seen much change?
Yeah, there's another notebook called Marimo that also does reactive notebooks. It's interesting, actually. At that JupyterCon that I went to, they had a poster session the night before the conference where people were presenting sort of experimental work. And there was a guy there in 2018 who had made an experimental reactive kernel for Jupyter. And so a kernel is basically the computational engine that sits behind it. And reactive kernel just means that whenever you change a cell, all the cells that depend on it update. And so that makes it so that you can't get in this weird hidden state, because if I change a cell that something else depends on, that thing that depends on it recalculates. And so the state stays in sync. And so I argued with this guy for a while. I tried to get him to bite the bullet that every Jupyter notebook should work in this reactive kind of way. And he wouldn't bite that bullet. But it is a little bit surprising to me that, the core notebook product hasn't, gone through that many changes that would help with this. It's been, 7 years?
What is it that you think people like about notebooks so much? Because there's no question they've been deeply adopted by the data science and data analysis communities.
So there are a few things that people like. One is this notion of literate programming, right? So in addition to having these code blocks, I can put in, here's a markdown block that's going to explain, here's what I'm about to do. Here's what I'm about to do. And so it makes for a very readable document. Whereas if you had a script in a Python file, it would be much less readable as a document. Along similar lines, one thing that they do really nicely is that they allow you to intermingle graphical output and text output, right? So you say, here, I would like to run a regression, and now I'm going to, put the graph and a table of the regression coefficients right underneath it. And so as I read this thing top to bottom, it's got code, it's got equations, it's got explanations, it's got charts, it's got tables, and it makes a really nice artifact, right? Here's the exact details of what I did and what the results were. And so to the extent that you use it as an artifact, I think it's actually, pretty nice and gives you a good way to look back at, here's what I did. Where you start running into trouble is when, okay, this is not just an artifact, it's more of a living document. I want to go back and change this part of it, and then what happens to the rest of it. And, people sort of tie themselves into knots, and, maybe they haven't specified, here's the exact dependencies I need. And so they get sold not just as artifacts, but also as, this is the key to doing reproducible research. And
Sure.
It's like half the key to doing reproducible research. The other half is having the right environment. And, you can put some pip commands in the top cell and do things like that, but it requires a lot of discipline to use them in a way that's really reproducible.
Yeah, dependency management is a problem. I think probably 90%, maybe more, of people that work in notebooks run them locally. So that's another potential issue. Collaboration is pretty horrible. Trying to manage notebooks in like a GitHub or sending files back and forth. Like, that's a headache, trying to get someone else's notebook running. Have you ever done any collaborative work, like using maybe like a Google Colab or some of these more modern kind of notebook environments that they've essentially cloned Jupyter and they put it on the web and stuff like that?
I haven't. I mostly work in code, and so for me to collaborate is really around writing scripts. When I was at AI2, we did a lot of experiments, and the way that we aimed to have them be kind of reproducible was by having them driven by command line tools with kind of these hyperparameter configuration files, right? So here's a script that's going to read in from a config file that says, use this many hidden layers, use this many input dimensions, use this embedding model, and so on and so forth. And that way, if you have, a variety of these blobs describing experiments, you can just say, let's run all these and collect the results. And so that's the way that I've typically worked. When Streamlit was big, I used it for a lot of, I would say, more interactive demos than notebook replacement per se. More, here's a model, I want to give you an easy way to play with it. You being someone who's not a coder maybe necessarily. And so I've had a lot of good luck with that. I haven't done much of that recently, but yeah.
Mm-hmm. Got it. Well, maybe we'll segue a little bit into Zerve and what we've been doing in the space, because we are releasing on Wednesday what we're calling Notebook View. And on Friday, I think we gave you access to it to kind of look at it and play around a bit. So you're by no means have gotten to get your fingers as dirty as I'm sure you want to. But I did want to pop up a few things. Let me share my screen here and just talk a bit about kind of what we've been thinking about in this space, and maybe just go back to our original example. A equals 1, and then add 1 to A, and then print it. And I've gone ahead and run these cells, and you'll notice that A here is 2. It's always going to be 2 because of the way Zerve is architected. So we call this notebook view, but it's not really a notebook in the sense of any traditional notebook. It's more in that it looks like a notebook in terms of the way you interact with the code. So what each of these cells in Zerve is doing, and I know you know this, but I'm just sort of explaining to the folks that are listening. When the code executes here, you notice you've got these 2 arrows here. These are your upstream dependencies, in which case, in this case, this block doesn't have any upstream dependencies. And in this case, it has 1 downstream dependency, which is this next cell. And so we're tracking which cells are related to which cells. But when this block executes, it's actually storing its output. So one of the big issues for me with running notebooks is that if I send you a notebook, then you can see all of the charts and graphs that I might have printed out, but none of the variables exist in your version of it, because notebooks are typically in-memory tools, right? You'd have to execute the code in order to actually see the values of any variables. In Zerve, it's super different. So in Zerve, when I run this code, what we're doing is we're caching and we're storing all of your variable values, and then we're passing them downstream to any variables that or any cells downstream that might actually need to use them as dependencies. And so this variable A is getting stored. And so if I were to share this with you, and you were to log in, we could all be logged in together, and we'd all see the values of these variables as they are run, and what they're stored as. And so that's the reason that every time I run this guy, it's starting with its dependencies. And so it's saying, oh, A, which A? Oh, it means this A, and that A equals 1. So I'm going to add 1 to it and print it. So no matter how many times I run it, in this case, 1 plus 1 always equals 2, just because of the way that we've structured the notebook. And so it's actually significantly different from the way that notebooks today typically function, because of the way we have the architecture set up.
Yeah, that's helpful.
In fact, another way, the way that we've always had to look at these guys before is as a DAG. And so this is another way of visualizing that exact same project, where we've got one cell that, or in this case, the block, but this is the same project. It's just viewed as a DAG instead of as a notebook. This cell executes, and then it's passing its variable space down to subsequent blocks, where when those blocks execute, then they start with the starting points, and that way the results are repeatable, reproducible, and the same every time. And you can't get into that bad hidden state situation that you often do with notebook environments. So I'm actually really curious about the way that you work when you're writing code. My guess is that you're typically in like a .py file in like a VS Code, kind of a very hardcore type engineering type environment. But when you do have like, like visualizations you want to look at, when you're doing data exploration and things like that, what type of environment do you find yourself working in?
So I have forever been a big user of the IPython console. I don't even know if it's called that anymore, but that's what I call it. That's what it's always been called. And so what that is a terminal-based console that has a lot of the IPython or Jupyter magics, if you will. And so, in some sense, what you could think of it as an append-only notebook. And that's another thing that I actually have talked with them about before too, is, if you could make notebooks so that they were append only.
Tell me what you mean by that. What do you mean by append only?
What I mean is that once I run a cell, I can't change it, and I can't change any cells above it.
I see.
And so the way I use, IPython the console is like, once something has run, it's run, and it's there in the terminal history. And I can now overwrite it by saying, again, A equals 3, when before I said A equals 2. But if I scroll back, I'm going to still see the A equals 2. And so, that was another thing that I pushed the Jupyter folks on, several times, is what if you had a notebook kernel that was append only, so I can only add new cells at the end, or where if I go back and change a cell, it gets rid of every cell after that. And so I'm basically rewinding, but then I'm starting from where I rewinded, and I can't keep the other things that I've done since then.
Gotcha. Okay, I can see that as another workaround of that hidden state problem for sure.
Yeah, I'm not sure I call it a workaround. I just think it's a different paradigm that doesn't, allow the hidden state.
One of the things that I've seen quite a lot is wanting to schedule a notebook to run on a recurring basis.
Yep.
Do you ever go down that road? Do you play in that space at all?
I don't. I'm not much of a data engineer, and so I've seen that mostly in the data engineering space. I have a pipeline that runs every night, and I want to, take the output of some, job or table or whatever, and pipe that through this notebook, and then put the output there. So it's basically, the notebook contains my, ETL rules, and so I've seen that happen, but I generally am not involved in that part of the stack.
Gotcha. And is that a good way to run code, like to run a recurring job as a scheduled notebook, or how would you do it if you were going to? Do you have a script file like a cron tab, or do you, what kind of scheduler do you think is the most useful when it comes to like data pipelines and things like that?
Again, I'm not a data engineer, so I'm not gonna make. I don't have strong opinions on that. I think So here's what I'll tell you: is that all else being equal, I would prefer having my data transformations written in code. That way, they're easier to unit test, and I can use my IDE to edit them, and so on and so forth. I think the teams that I've worked with that used notebooks as for these data engineering pipelines, the value to them was that they would generate charts and graphs as part of the data pipeline. And then, as we were talking about earlier, then they would save this as an artifact. And so now when I want to understand what did my data pipelines do last night, I don't just look at logs necessarily, but I have these notebook artifacts that I can look at and understand better. I think there's some questions.
Oh, okay. Here's one. George says, we've seen a lot of new tools promise reproducibility, but they end up locked into proprietary formats or hosted runtimes. How does Zerve avoid becoming another walled garden? Good question. Zerve, so we don't create any proprietary formats. All of our code is just straight Python code. And when you connect it to GitHub or Bitbucket or any of the hosting tools, it stores your code as plain text and so on. So we're using kind of open source technologies to preserve all of that sort of thing. So you can always kind of take your ball and go home if you want to jump out of Zerve into some other type of environment. I should mention also, by the way, for the folks that are on, if you want to sign up for Zerve, it's free to use. So you can create a free account at zerve.ai and get in there and connect your data, upload data, use our agent. In fact, maybe that would be a good thing to do now, is just kind of demonstrate what our agent actually looks like. Let me share my screen again. And I will just jump in here and I'm going to say, I'm sharing my screen, right? Yep, I'm sharing my screen. I'm going to say I'm doing a live stream and I need a cool demo. Use made up data. So we're connected. So this is all running in the cloud, and we're connected to in this case, it's running in AWS, and we're integrated with all the various large language models. And we've built an agent that can actually do some really cool stuff in terms of like writing code and running code and executing code. And in this case, it started in DAG view. So I'm going to go ahead and just jump over to, so here's its plan. I'll just read through this plan real quick before I switch to notebook view. So it's going to generate some data. In this case, it's chosen to create an e-commerce data set, and it's going to build some parallel branches with sales metrics and customer segmentation and stuff like that, and then make a dashboard. So I'll just click Approve Plan. But let me go here and just jump into Open as Notebook. And we can see that same, as it starts to write code, it'll start to create those blocks inside of this notebook, and we'll be able to see what it's doing. So Joel, while it's thinking, it started to create some data already. We'll look at that in a second here. While it's thinking, what have you seen in the collaboration space? So in terms of like data scientists wanting to work on creating projects as a group and coding as a team, how are people doing that in your experience today? And is it working?
You see a lot of people using Jupyter Lab And so, I've worked at companies where they set up big Jupyter Lab instances. So that's like a hosted Jupyter Notebook server where people can share notebooks on the server and work on them. Now, I don't know that admits kind of multiplayer editing, if you will, but
Mhm.
I think that still is a pretty common way of doing it.
Okay. Yeah, so I've tried using tools like Colab and a few others, and I always find that it's a bit sketchy in terms of getting kind of collaborative coding working, especially when you want to run your code. The way that Zerve actually executes is that each cell has its own kernel, basically. So when you click it off, when you click run on a particular block, now the agent is doing all the running here. And so you can see it's creating a boatload of code. And here's, like, for example, the data summary of the data set that it created. But when each of these cells ran, they actually spun up serverless compute to actually execute the code. The default is using lambdas, but you could change that to GPUs, or you could change it to like Fargate containers, but it all runs serverlessly. And so one of the upshots of that is that you could execute code you could run as many of these blocks or cells at the same time as you wanted, and they don't interfere with each other. And the project is smart enough to know where the dependencies are. And so if I made changes to this block and then executed it, then the downstream blocks, they wouldn't automatically update, because we don't want to mess somebody up if they're working downstream and the upstream data happens to change. But the blocks are smart enough to know that there's been an upstream change, and that everything needs to be re-executed in order to reflect the latest data. Like, for example, if we go back to our DAG view on this graph, you can see there's quite a lot of like a nonlinear process that's being created here. And if I kicked off all of this to run again, you'd notice that you could have multiple blocks running simultaneously. And so each one being independent and knowing what the dependencies are makes it really useful when it comes to wanting to run stuff in parallel and wanting to collaborate with other teammates. So do you see a need for something like that? We certainly have talked with lots of teams where they're like, collaboration, we don't really do that. Is collaborative real-time, like synchronous collaborative coding, is that a thing that you think is going to grow, or is that going to be something that's like teams don't really do that? Or what are your thoughts on that?
I think what's probably going to grow is real-time collaborative coding where you're collaborating with the AI. Is more likely to grow than collaborating with other people. I mean, if anything, the way the world seems to be pushing a lot of this work onto the AI, like you just did.
Right. Yeah, that's fair. That's fair. So the collaboration would be more in terms of like handoffs from team to team, say?
No, I mean that's one aspect, but another aspect, you could imagine collaborating with the AI, right? Like the AI is making changes, I'm making changes, we're trying not to step on each other. I don't know that the current coding assistants are good at that right now, but I feel like or multiple people will spin up multiple Claude codes or multiple Codex CLIs at the same time and try to get them not to step on each other, right?
Right. Yeah, so we do something similar there. So if we wanted to kick off a new chat and say, hey, could you explain what this code is doing, please? Then, you see how you can have multiple agents kind of doing all sorts of stuff at the same time. And getting them to not step on each other's toes is, I think, a sort of an unsolved problem at the moment. The way that we've tried to tackle it is by controlling the scope of what each agent can do. So if I jump back to the notebook view here, I can pick one of these blocks. Ooh, this is interesting. Remind me to come back here to this block here, because the agent is self-healing. It's created some code that it's got some errors in it, and it's made a mistake. And so it's going to go back and try and fix it and self-heal and all that kind of stuff. So that'll be interesting to see if it'll work. But I can go in and I can.
There's a couple more questions.
Oh, do we have more questions? Sorry, I'm sharing my screen and I can't see the. the thing. All right. In practice, most data teams mix code from multiple languages and environments. How does a Canvas model handle that complexity better than just gluing together scripts and notebooks? Have you experienced that? Do you find teams working in multiple languages and trying to knit all that together?
I've seen it before. It depends on the organization. I mean, some organizations leave it up to the team, and so you have a team that works in R and a team that works in Python, and maybe even a team that works
SQL.
in TypeScript. Yeah, I mean SQL. Yeah, SQL I guess is a good example. And then some teams are much more standardized. I think it goes both ways. But yeah, it's definitely a real thing.
So the way that we handle it, when each code block executes and serializes the output, that does something kind of unexpected, I would guess. So let's say we were doing some pandas code, and we execute that code, and we've got a data frame. That data frame is going to get serialized, in most cases, as a Parquet file. And it turns out R knows how to deal with Parquet, and SQL knows how to deal with Parquet. And so in the deserialization step, when the next block runs, it might be an R block or a SQL block, and they can use those Python objects directly in Zerve. So within a single Zerve notebook or a single Zerve canvas, you can use R to visualize a Python data structure, or ggplot to plot something from Python. You could SQL query a pandas data frame. And that's all sort of by virtue of how the serialization and deserialization steps impact the way the code runs. So we've seen a few teams that have actually most commonly, pardon me, most commonly the managers are using R, and the team is using Python. There seems to be an age gap between R users and Python users. And so a lot of times we'll see a manager that uses R and a team that runs Python, and the manager wants to get in there and get his hands dirty, or her hands dirty from time to time. And being able to do that interoperably between languages can be really interesting. Let's see. You're framing the canvas as a kind of bridge between exploration and production. Does that risk satisfying neither side? Too rigid for discovery, too visual for engineering? I'm actually really curious about your answer to this question. What would it take to get you using something like a Zerve for something like a production process?
So here's where I think my challenge would arise, is that the sort of experiments that I need to do involve interacting with systems that are maybe running locally on my machine, right? So maybe I have some kind of service that's running locally, and my experiments need to be making calls to this service, possibly in a decoupled way using like REST APIs, but possibly in a more coupled ways. And so because of that, for my use cases that I have today, having sort of a cloud environment, whether it be a Jupyter lab or a Colab or a Zerve or whatever, will be a little bit tricky, I think.
What are some examples of those local kind of connections that you need to make, just so I can?
So for example, let's say I have an AI-enabled SaaS product, and it has backend services that are powering it. And now I want to do experiments with where I'm, changing some of the parameters that the system runs with. And now I want to see, are the results better? Are the results worse? And I need to do that by, potentially stopping and restarting the system, or running multiple copies of the system. But I have services running either locally or in the cloud somewhere that will be a little bit more work. It's not impossible to talk to them from, a hosted notebook or whatever, but it's a little more work than if I just want to run some kind of hermetically sealed experiment where the notebook contains everything that it needs to know.
Right. No, that totally makes sense. How do you think self-hosting it's, to me, so I do all of my data science and data analytics, pardon me, in Zerve now, in the cloud. And I would never, ever want to go back to local development. just because when I have something that I want somebody to look at, it's just so easy to just send a link and share a project. I view it as kind of like moving from Microsoft Word to Google Docs. Like who in their right mind would ever use Google Docs now? Unless there was some forcing function that required you to. Like the only use case I've seen is legal, like law firms that need, some sort of a Word feature that's not available in Docs.
Well, Microsoft Word is a cloud program now, so.
Well, yeah, maybe.
It is. I promise. I used it in my last job. So.
Oh, okay, righto. Well, anyway, they certainly caught up, I guess then. But
yeah.
Just from an analogy perspective, to me, moving from Jupyter to something like a Zerve or a cloud-hosted notebook, there are major advantages to doing that. Do you find that to be the case? Or is it just me and the way I operate?
No, I mean, I think there's there's pros and cons to everything, right? So some of the things you're saying about making it easier to share, making it easier to have multiple people working on stuff, certainly that's the case. And if those are the things that you're optimizing for, having a way of hosting it, be it Zerve or Jupyter Lab or Colab or whatever, helps with that. At the same time, you're giving yourself an extra dependency. You can't work on an airplane if you're the sort of person who works on an airplane. I can't work on an airplane because there's not enough room to open my laptop, but it's a different issue.
It might be a benefit, I guess. No, I'm kidding. Right. In terms of the stack and how it's moving to the cloud for data scientists and the way that they operate, have you seen any trends that are interesting in that space? Here's part of what I'm thinking. So like during the pandemic, I was at a company called Data Robot, and we were doing some work with Health and Human Services on simulating the effect of recruiting for the vaccine trials in different areas. And so, if you recruit here, this is how many people that you'll get, and this is how long your vaccine trial will take, given certain assumptions and so on. And at the time, there were thousands of people dying every day of COVID, and so it felt to us, whether it was or not, it felt to us like what we were doing every minute mattered in terms of like being able to help. Now, it's a thorny and political thing to talk about, but just in terms of like data science and infrastructure and stuff like that, we were working in notebooks, and we were like trying to email and Slack notebook files back and forth, and do that whole thing, and getting to the cloud and handling like the orchestration and provisioning resources and stuff like that was not something that we were able to do quickly, and so that was a major stumbling block. And some of the folks that are using Zerve have made a similar observation.
Yeah, I think that's a fair point. And I think also one thing that I've seen over the past 5 to 10 years is that a lot of companies that had been reluctant to move to the cloud more broadly, not just in data science, have really embraced that. And so there is a lot of appetite for, we want to embrace cloud solutions to things.
All right, so maybe we'll wrap up a little bit here. What's next? What do you see as the big, like if you had to put another talk, rewrite it out there? I don't like X about the data science development a space, the toolkit that's available to data scientists. What's Joel Grus Part 2 at the next JupyterCon event?
Honestly, it's been, the talk would be, it's been 7 years. Why haven't you fixed all these things?
Yeah. All right, that's fair. Oh, we got one more question, then we'll go ahead and wrap. It says, you both talked about determinism and hidden state, but isn't some amount of non-determinism inevitable once models, randomness, and APIs enter the picture? How far can tools really go to enforce reproducibility?
So I think, when I was at AI2 and we were training our own models, if you have a model that runs on a single GPU and not in parallel, and you're setting the seed, then it is like pretty reproducible. Like you'll get the same result every time. Now, if you're running on multiple GPUs, or if it's a hosted model, maybe it's a little bit less reproducible. But I think, if you're calling, GPT-5 and you set the temperature to 0 and you give it the same, you give it the exact same model date and whatever, then in theory you should be getting the same sorts of things back. So I think, so I'd say I think there are ways to get things pretty reproducible in most realistic cases. I mean, if you're a data science team that's training XGBoost models or whatever, you can get the exact same one back, I think. And the second thing is that, if you actually do have a model that is so non-deterministic that when you run it with the same inputs, you get like vastly different answers, and you can't get the same answer every time, I think that tells you something interesting too. But
Yeah,
like
you've done
I
something
do.
wrong.
Well, no, I wouldn't say you've done something wrong, but what I would say is that you haven't, maybe solved the problem as well as you think you have. If your solution only works half the time. But I do cling to this idea that I think things are, can be reproducible if we take the right steps.
Awesome. Well, hey, Joel, thanks for taking the time on this beautiful Monday morning. It's a pleasure to get to talk to you. And I'm really sort of optimistic about how the data science coding kind of landscape has changed. The way I code is totally different than it was a year ago with the large language models that are out there, and with the environments that are coming and all the tool changes. It seems like, I mean, you always hear this, that the pace of innovation or change is fast, but it seems like it's even faster than it has been. Is that the sense that you get?
Yeah, every month I have to cancel one $200 a month subscription and sign up for a different $200 a month subscription because it's better.
Awesome. All right, cool. Well, Joel, thanks again. We really appreciate it. And
Yep.
this was a really great conversation. I would remind anyone that's
always glad to
listening.
chat.
Excellent. Anyone that's listening, you can go to Zerve.ai and sign up for a free account. Get in there and give it a try and send us your feedback. We'd love to hear it. Thanks for joining, everybody.